This video merits a train whistle. I am in my series. I'm on video 731 or something like that, about building a color classifier. I'm trying to look at the overall concept of machine learning and building a color classifier. So where am I? I spent a bunch of videos kind of crowdsourcing and cleaning data. And where I left off, I have this JSON file that has a whole bunch of data points in it. Each entry has an RGB value and a label. So there are 9 labels, and there are obviously millions of possibilities for the RGB values. So what's the next step here? Oh, so many things to think about. Let's go back to this tutorial that I referenced that's part of the ML5 project called Making Your Own Data Sets. This is by artist and researcher Hannah Davis and other contributors who may have also edited this page, but it started with Hannah Davis. I'll link to information about her and this video in this page in the video's description. Now, one thing you want to look here that I think is important is preparing your data set for machine learning, training, testing, and validation. So I forget, the first thing, let me do something first here. Let me actually write some code, strangely enough. And I've got P5 loaded up here as kind of like a base JavaScript library that I use. And I'm going to add the preload function. And I'm going to say let data. And I'm going to say data equals load JSON. And it's called color data.json. So I just want to load that file. And then I'm going to say console.log data.entries.length. So let's just see how many data points do I have. Let me make sure I can indeed load that file into my code and look at how many data points I have. So here we go. Oh, I'm in the wrong sketch. I changed it to here. 5,643. I can read numbers. Is that number perhaps that number could be found somewhere in my random number book, but I'll look for it later. So okay, why did I say that? So if we come over back to this page that I was referencing, and we need to, if I'm going to build a classifier, the way I'm going to do this is by having training data and testing data. Now, there is also something called validation data. And let's go look back at this web page. Training data set is used to train the model. Validation data sets are used to change the parameters of the model. So I'm going to, for the purpose of this video, kind of simplify by not worrying about validation data. And I am just going to use training data and testing data. And the idea here is that what I want to do is train the model with my training data, but then I want to feed it the testing data and see if the labels that it returns, oh, it thinks this color is bluish, is that actually what it is labeled with? And I'll get some type of accuracy score from that. And I'll know more about, I don't want to test it with stuff that I've trained it with, because of course it's going to ultimately get that right. Machine learning models are very good at returning the result that you tell them about. And we need to see, does it also return the result of new data that it hasn't been trained with? If it works really well with the training data, but not with the testing data, this can be known as overfitting, meaning the model is just incredibly good. It's so exact that it doesn't really know what to do except for like the exact data that it was trained with. So this is what we want to watch out for. And a kind of convention, let's say I have 5,000 data points. A convention might be to use 80% of those. So 10% is 500, so like 4,000. 4,000 is 80% of 5,000, I think, as my training data, and then save 1,000 or 20%. 1/5 as my testing data. All right, so I need to, at least at the beginning right now, divide it, and I might just sort of pick randomly to divide it up. Okay, so conceivably what I want to do now is look at this data.entries and divide it into 2 different arrays, training and testing. But here's the thing. What I'm kind of talking myself in circles here, but I don't want to split it just yet, even though that was an important point for me to make. I'm using TensorFlow.js here, and TensorFlow.js actually has a function called split that will let me take long list of data points and split them into two different lists of data points. So what I actually want to do first is get the data into Tensors, the TensorFlow.js thing that I need to use it, and then I'll call tf.split to do the 80-20 split. So how am I going to do this? How am I going to convert it into Tensors? Now, first of all, if you have never looked at TensorFlow.js before, I might encourage you to go watch my TensorFlow.js tutorial series, and it looks at what is a tensor and what are the possibilities there. But just thinking about it, the thing that I need to do also is think about, I have the inputs, which are the RGB values, and then I have the target outputs. The target outputs, which are the labels. And so when I create my tensors, I'm actually going to do this somewhat separately. So let's just worry only about the inputs. This is going to be the easier part first. So the inputs, basically, the tensor shape that I want is a 2D tensor, right? Because each input has 3 values, maybe a R, G, and a B value. And then I have a lot of those. So a 1D tensor, like a one-dimensional array, just has a single set of RGB values, but I have a 2D tensor because my data set is a whole bunch of those data points. Okay? So let me first just create a tensor 2D out of all of the RGB values. And by the way, if you watched my XOR coding challenge, where I did kind of a basic, where I trained a neural network to solve exclusive OR, I also was calling these X's. Can you see that? Barely. And the outputs being the Y's. So that's the X's are like the inputs to the machine learning model. The Y's are the outputs. So I might use that variable naming as well. OK, now I'm really going back to the computer. And I'm going to say, so let me first, to make a tensor, I need to normalize the data and put it into arrays. Whew. So let me go here and say, first I'm going to say let the colors be an array. Then I'm going to go through, let every record in data, let record of data.entries. I'm going to say colors, and then I'm going to say I'm going to have a specific color. I'm not going to use the word color, just going to say COL is record.r divided by 255, record.g divided by 255. And I'm dividing by 255 because I want to normalize. It's going to, generally speaking, for my inputs to a machine learning model, I want to normalize to some strict range. Between 0 and 1 is a pretty good one to do. And then I'm going to say record.b divided by 255. And then I'm going to say colors.push, cull. And then just going to look at this, colors. Let's just look at this. So this is not a tensor yet. This is just 5,000. And probably one thing I should do while I'm working this out is I should work with like a smaller data set. But 5,000 is so small anyway. But if I were doing this with like a big data set that had like 5,000 records in it, I'm like sort of figuring out I would want to do it for just like 100 first, and then I could use the large data set. OK. So we can see here this is a big array, and each element of that array is another array with the normalized color values in it. Perfect. So this now, I should be able to say now, let x's equal tf tensor 2D colors. So this is me turning those values. And I just want to say like console.log x's shape. Let's look at the shape of the x's just to sort of see. Yes. Right? There's 5,643 entries, each with 3 values. So I think things are going right here. I turn that into a tensor, and then, oh boy, hey, this wasn't so hard. We're in good shape here. I haven't done the training or testing. Now I need to do the Ys. The Ys involve a concept known as one-hot encoding, I think. One-hot vector. So you know what? I'm going to pause here. I finished this video. I'm really dividing this series into like little chunks here. In the next video, I'm going to look at how to make the Ys, and I'm going to cover a concept known as one-hot. One-hot. What's the term that I'm looking for? Is it one-hot encoding? One-hot encoding, yes. So I'll cover that in the next video when I make the Ys. Thanks.